Welcome to qnawire.
We know rate, or the activity, is going to be equal to the change in the number of radioactive nuclides per change in time. Or another way to look at this is the rate, or the activity, is going to be equal to K, the rate constant, multiplied by the number of radioactive nuclides that we have at any given time. We can solve for K by using the half-life equation and the half-life value. Natural log of 2 divided by the half-life in years is going to give us the K value in units of 1 over years. Then the number of radioactive nuclides that are present during the time of ingestion will be the 1 microgram converted to grams. Then we'll convert the grams into moles of radioactive plutonium-239. We weren't given a molar mass, so we can estimate the molar mass with the mass number, 239. Now we have the moles of radioactive nuclides. Let's convert them into actual number of radioactive nuclides, which is what we need for N. To do that, we'll multiply by Avogadro's number, and we get 2.52 times 10 to the 15 radioactive nuclides that would be present in a 1 microgram sample of plutonium-239. Then we can take the K value and the number of radioactive nuclides at the time of ingestion to calculate the activity at the time of ingestion. Multiplying those two together will give us the number of decays that will occur per year, 7.25 times 10 to the 10. So the person ingested it, and it was present in their body for 16 hours. So we'll take the 16 hours and convert them into days, and then convert the days into years so that we can use this to figure out how many decay events occurred in the 16 hours, but this has units of 1 over years, so we need to get our time into units of years. Now we have the years that correspond to 16 hours. We can then convert to the number of decays that correspond to the 16 hours that passed. Now that we know the number of decays, we can multiply it by the energy associated with each decay, which was 5.15 mega electron volts. Then we can convert the mega electron volts into joules, knowing there's 1.602 times 10 to the negative 13 joules per mega electron volt. Now, in order to get grays, we need to take the joules that we just calculated, that the individual was exposed to in a 16-hour period with this activity, divide that by the kilograms, the mass of the individual, and we'll get 1.29 times 10 to the negative 6 joules per kilogram, and a joule per kilogram is a gray. Then to convert it to rads, we know that there are, in 1 rad, 0.01 joules per kilogram, so that conversion gives us 1.29 times 10 to the negative 4 rads that the individual was exposed to.